Okay, yeah, so thanks everybody for sort of hanging on, and really today I'm going to talk a little bit about security at the speed of DevOps. Hopefully this will, I kind of say kind of, because hopefully I'll have a little bit of something for everybody regardless of background. Okay, so a little bit about myself. I'm the head of DevOps at Barclays in the Chief Security Office. So what that means is I essentially manage, run and maintain all of the infrastructure that keeps the applications that keeps the bank safe. I'm also the head of all of the environment, so everything from vulnerabilities, patching, all of the cool sexy stuff, not really. And then finally the head of the physical security. So if you imagine like fingerprint scans, facial recognition, CCTV, all of that cool stuff. I also head up the sort of infrastructure side of that. So quite a heady responsibility, and really to be in that role, you kind of need a bit of a diverse background, which is why so I'm an expert in AI, specialist in physics, and major in neurocomputing. I won't dwell on that too much, but the kind of point I want to aim at is I've worked in sort of China, India, America, and Europe, and it kind of give me a holistic view. So spoiler alert, software development is the same shit wherever you go. Yeah, so I think I've maybe jumped off with the, oh, there you go. Okay, so I'll give you a cat picture, a cat video to watch while I talk about the agenda. Essentially, I'm going to start off with a little bit of scaremongering. I'm hopefully going to try and make you realise that security is actually quite hard, and then I'll continue with a little bit more scaremongering by talking about this cyber threats in general, and kind of give you like a holistic overview of all the potential concerns that a cyber analyst needs to worry about. I'll then sort of focus on this idea of pragmatic DevSecOps and why we need to be a bit more pragmatic. And then I'm going to give 6 high-level suggestions, so business and sort of leadership, and then sort of 6 quick wins for sort of low-level techies. And then I'll finish off with, I'll talk about what a compliant AI secure infrastructure might look like. Sounds pie in the sky, it'll be quite simple once we get there, so don't worry. But that's essentially it, so let's go into the fear-mongering, and if you haven't guessed already, I talk at 100 miles per hour, and I hope that you can all understand my overly thick, exaggerated Scottish accent. Okay, so let's get started. One of the things is, we talk about security and tech, and we talk about being on the forefront, but we often forget there's like this misconception that the old legacy security issues go away. There's plenty of people who fall for this and this. So, is the question, do HR need to maybe understand levers a bit better, or do we just need to lock the server room? But then also like intelligent systems are quite easy to fool. So you can fool a human with this one, like is it a chihuahua or is it a muffin? But also computers get fooled because they have very low amount of features, so they're quite easy to fool. And then finally, from a security point of view, if you imagine like you uplift all of your security infrastructure to use really advanced AI, you can fool lots of AI systems with just a couple of pixels. So we're in this situation where it's quite tricky, and a lot of engineers want to fall back into their shell and use the old traditional ways of defense and security and infrastructure, but that's clearly not the solution. And so we have this paradox, right? So we have this idea like we want to keep the bank secure, we have all of these vulnerabilities, all of these threats, but from a business and DevOps side of view, we can't just take the show off the road. We can't stop servers to fix vulnerabilities and run out patches. So we have this need to go fast, but also to be secure. So that's kind of really the aim I want to get there. And eventually I'm going to continue to scaremonger, right? So now imagine you're a DevOps guy, or you're sort of a business, you're maybe a decision maker, and you need to pick the tools for your company if you're a startup or if you're an enterprise. This is, I guess this complements the gentleman's earlier map. This is just the DevOps tools only, and I'd actually, this is a bare minimum. I would expect DevOps engineers to know, at least, I would say at least the major constellations. So So, okay, now you've got a strategy, you need to know what tools am I going to buy, but the problem is you might buy some of them and then be incompatible with the other tools. So really there's this layer of risk in the decision process. A lot of companies, big banks and small organizations decide to go with take a rock star who will take the leadership, and that rock star will clear the way. But the problem is if you trust a rock star, they'll take you down the journey that they want you to go down, not necessarily what's best for the business. So I just want to kind of highlight that risk. And one more, I'll not dwell on too much, but open source software is full of bugs and vulnerabilities. And I'll not dwell on it, but major organizations are moving more and more to open source, so even big banks, and I have yet to see an effective screening mechanism in any organization I've worked, and I've worked in China and India and the UK and America. And so you kind of need to think about we need to employ people who, as part of their job, is to look at the new tools that we're using in the new software, and is there any bugs, what is our appetite, and things like that. So the summary so far is we've got a paradox. We have all of these complications, vulnerabilities, and attack vectors, but then we also have this need to be more resilient and to deliver to customers' needs. Because customers are more they're less forgiving now, right? So if the bank went down in the 90s, people are just well, the bank's down. It's on the news. Oh my God, the bank's down. If the bank goes down today, people are I'm switching. And so that's a big problem that we have to deal with. So first up, I'm going to thank Zebia Labs because I shamelessly stole their periodic table, but I converted it for my own use. So they have a periodic table of DevOps tools. I've got a periodic table of cyber threats. So a big shout out to Zebia Labs for that. Okay, so I'm going to talk about a few of them. I'm not going to bore you with all of them, but I'll give you an idea, right? So security frameworks. If you're a leader or if you're a senior application developer, you need to think about what frameworks work best for your company. Some of these are legally binding and some of them are best practices. I recommend the NIST framework. It was rolled out by Barack Obama. It's used in the military industries. It's also used by big banks. What makes this so good is it's got a layer of language for every level. So if you're a project manager or if you're a business acquisition, you can work with the NIST framework and understand it at your level. If you're an application developer, does anybody here, any developers here? Hands up, anyone? Right, just, okay, so OWASP for you. And then any cloud developers, anybody play with cloud a lot? Right, C* for you guys. Okay. So hacker frameworks obviously are a lot shorter because a hacker framework, a hacker life cycle is much shorter, right? They generally trend to two paths. They either trend to jail, right, or they prison, or they trend to becoming a cyber analyst themselves, or they pack it in. So, but the framework I would recommend for a hacker framework would be OSINT, especially if you're a security person, because to make the shield stronger, you need to play with the sword. And OSINT open source intelligence is really good. Anybody here not from Europe and not from America? Right, so if you think that this isn't of a concern, like in terms of GDPR and PSD2, I can say that's not the case. So around the world, in India and China and Africa, data compliance is becoming more and more important. So it's a common trend, and we need to worry about that regardless. I guess it's kind of educational, right? But here's all the different kind of attack vectors. There's only about, what, like 16. But I would expect the average person to know these, or to know at least maybe 5 or 10. I would expect a DevSecOps engineer to know about 50, and I'd expect a cyber analyst to know about 80. In the world, there's over 1 million, so that's the problem. Okay, I'm not going to go over all of these, but you get the point. Social engineering, I kind of have to stop on that one because of all the systems that can be hacked and exploited, the human systems are the easiest, and they're the most dramatic. So, I mean, you'd be surprised how many phishing scams there are. One last one before I skip this is AI attack vectors. So if you think cyber attacks are bad just now, and if anybody's seen the news today, by the way, Labour's been hacked, and they claim that they've managed to successfully stop it. It was a DDoS attack. Looking at the attack profile, I think there's some AI in that. And so this is like what we're going to see in the future. We're not only just going to see high volume of attacks, we're going to see intelligent attacks. And so the need for better frameworks and defenses are really important. That top one I invented, and so you can check it out in the notes at the end. The point I just want to make is if you think things are bad just now, imagine a virus on your computer that trains on your computer and learns from your actions. It doesn't need to connect to the internet, it just learns from you. That's really bad, because that means it can evade antiviruses and just sit there, keylog, get your bank details, understand you as a person, right? So it might not need to get sensitive information, it could just get information on the way that you transact and the way that you live, and that information could compromise you in different ways, or your friends and family. Okay, so hopefully I've convinced you, right? So scaremongering's finished now. So hopefully I've convinced you that it's a problem. The next thing I want to convince you is that it's clearly there is far too much for some Einstein cyber analysts to keep on top of, right? So it's just not possible for analysts to protect you from everything. So I think we need to move more into this world of a sort of a collective security awareness, or a community, like I guess, community security, right? Where we all think of security as a personal thing. I've worked a lot in Asia, and in general, I find in Asia people are a lot more street smart around security. They fall, like if you look statistically, we fall for phishing and personal social attacks much more often. And it is a big compromise to big organizations. So it's like, well, protect yourself and protect your company that you work for. And this isn't an endorsement of the tool, but this is one way you can do it, right? So one way is you can have like a gamify the system. Rather than having mandatory compliance, you make it a game. And you're like, okay, try and find a security vulnerability, now go try and fix it. So this is a great thing for developers and application developers, because you can, you can even pick COBOL or whatever language, right? I mean, and it will say find a vulnerability, fix the vulnerability, make sure it doesn't happen again. And then you're on a leaderboard and you can show off to your friends. But really what that is it's like a screen. So you could use it and say, right, before I let my developers touch production, or before I let my developers do anything naughty, I'll screen them with this and see when they get a high score. So it's a great way to move forward. So if anybody knows DevOps here, you'll realize just what a mess this is. In the advertised model, there should be about 4 or 5 steps. The point I want to get across here is, and I won't dwell too much, is try not to solve everything, because you might end up getting nothing. And if you're a champion of automation, you should also think about the human processes. Right? So a perfect plan always fails when you add humans into the mix, right? And so we kind of need to start thinking into the future, and I'll touch on that. But the main theme I kind of want you to think about taking home is like, probably the future is not going to be full AI and automation, and it's not clearly not going to be all humans. It's going to be augmented, some kind of a mix. So a really good tool is a tool that can manage both at the same time, and I'll touch on that. So I'll start with the simple stuff, high level, and then I'll get progressively more complicated. Generally, just for developers or any old companies here, most people now know how to develop microservices. And so the need to iterate in smaller chunks is really important. And also, if you're not familiar with application development or DevOps or security, I strongly recommend you to sit in a Scrum. So if you work in a tech company and you have your guys doing their Scrum, I strongly just suggest you to dial in and listen to what they talk about, because that will really help. Does anybody here, how many people here know what ITIL is, or change management? Right, okay, good, that's good. So I think we can all agree it's broken, and I'll give 2 examples. The first one is we raise emergency changes just to get things in on a Friday. And then the second is, let's say I'm about to make a big change in production. I go into production, I've got my change record, and I see something else that's broken. I'll just go and fix that. That's a problem, right? Because they're using the change to do something that they shouldn't be doing, even if it's a good thing. This was invented in the 90s, and it should have died in the 90s. So we really need to evolve ITIL. Some of it's boring, but compliance monitoring is, I think there's a thing called server spec, all the notes are at the end, but there are increasingly new ways to manage and automate human actions, like business actions and management actions, by creating essentially playbooks. And these playbooks, you can define certain ways that you can combine business risk and management risk using things like server spec. So that, I think, is a really good thing to look into. This is quite condescending, but I will just say anybody here that does DevOps should also practice what they preach. And what I mean by that is, if you're a DevOps engineer, comment your code, source manage your code. Don't just have Jenkins jobs with no descriptions, because everybody else has to look at that. As a DevOps engineer, so many people work with you, and yet they don't understand what you're doing. We have enough problem with AI and data scientists doing that, so we really need DevOps engineers to, champion Agile, what they say that they can champion. This is a more high-level one, but has anybody read the Phoenix Project? Right, so get rid of your Brents. Brent is a guy who is awesomely intelligent. He really gets the job done. Everybody relies on Brent. It comes for a Friday, well, I could learn it myself, but Brent will get it in. You need to remove your Brents and to remediate your Brents, and the best way to do that is to go up to Brent and say, Brent, you're off the bench. You're on the bench for a month. And he said, oh, we need to get the change in, or we've got product releases. But your long-term risk increases the more that you rely on Brent, and you have to draw a line in the sand somewhere. So my advice is, don't try to do it slowly, just take him off for a month, him or her off for a month, and get her on KT duties. It will be hard to get everybody else up to speed, but it needs to be done. Finally, this is what keeps me up at night, is vulnerabilities and bugs and issues on the servers, and I don't have any solutions because there's too many people who think there's solutions, yet we still have the same problems. My only advice is, you might want to think about two things: how you can combine all of your insights into one place. So my vulnerability scans and my patching scans agree. And the second is how you can, for example, if you use SSH or Ansible or Chef, create a way, like write a script where that you can look at every single machine or AMI or VM and just feel out and get a list of, here's where all the directories are, here's all the user groups, security groups, and understand what good looks like. Create your own template. From that template, you can then move into steps. So you say, this is a Linux template, this is a Windows template, and then slowly enforce that. So you start off to work out how much people deviate, and you try to bring them in over time. Okay, so I realize I'm cautious of time, so I'll move a bit quicker on the quick ones. Developers, DevOps, and testers, help your support team make ways that they can have things like buttons and Slack, so when they get an alert, server's down, and then they can just say, would you like to restart the server? Yes, push the button. A lot of us are millennials, and we have a low attention span and a low patience, so we may as well just make the chat their command and control center. It's easily done. You can just get 2 weeks of a developer's time and say, can you build a bunch of buttons and integrate into Jenkins? This one's for everyone. Evil user stories. So if you know Jira and Scrum, why don't you every sprint make one story, just one task, and say things like, how can I sabotage my product? How can I make it, how can I inject bad code? Or how can I reduce business profitability or increase risk, right? Do it as a Friday session for fun. Do maybe 5 minutes, 10 minutes, don't spend any more than that, and just ask people what's the worst thing that could go wrong? And then write a story about it. And then the next sprint, just have somebody look in and see if they can validate if those concerns are real or not. And that's you baking your technical debt into your activities. Okay, smart pipelines, I won't go into that too much, but for DevOps, you can use your logs. ML's getting easier and easier these days, so you can learn from your logs to predict when there'll be infrastructure failures. People get scared of that because DevOps engineers, the only thing that they don't know is AI. So I do think, because it's getting easier and it's out the box with Amazon, they should kind of embrace that. This is one for everyone. Humans and machines will eventually have to coexist in the one symbiosis. Like, don't just have service first for human management and then some orchestration for all of your automation. Bring them together. Like, map your automation and human dependencies. Zebia Labs have a stall. There are other tools out there, such as Urban Code Release. It died in the 90s. I want to bring it back. I think we should, because it is the future. We need to figure out how to manage humans and automated services in a one seamless way. I'm finishing up, I promise. But this one's the big one. Code amnesty, right? So I know that this is really like basic, but why not have a day where you can say, right, guys, just tell me the shit that's not working. Like, I'm not gonna blame you. I'm not gonna attack you, but just come to me and say to me, well, this server should have really been fixed, or this, I guess this program needs to be updated. There's a vulnerability here. We shouldn't have installed this application. And give the coders a chance to flag what we all know and make sure that the leadership are aware of it so they can just address it. But then don't punish them, right? Final one is there's cool tools for school. So things like, everybody here, please use Pond. Go to Pond as soon as you finish and put in your email address. See if your email address has been compromised. Right? I mean, you'll be surprised. It's like Pond. As soon as you Google it, it'll be the first search. Put in your email addresses and make sure nobody's taking your passwords. There's a few other tools such as Hack the Box I'd strongly recommend for pen testers, because pen testing part is the future. Okay, I will spend 30 seconds on this because I don't want to lose you completely, but the future of security, so this is just for the future, right? Security of AI applications is really, the way that we do it right now, if you imagine a company, they work with a third-party data platform or a third-party machine learning platform. We've got a mobile app. The customer wants to go to the checkout, they buy something, and we produce a fraud score. Now, big companies don't want to do that themselves, so they'll outsource the work to maybe a data company. The problem is that's not really compliant, because if you look at where the green goes into the red, what's actually happening is we're chucking data over the wall. And I, as a customer, I did not consent to you sharing my data with a third party. But that's what happens, right? And that's GDPR incompliant. The way to move forward is, and this is the final part, I promise, is where that little cog is, what we're actually doing is we're training on the client side. So we share with the third party what we learned from the customer, not the customer's data. There's some other things there, but that's the general idea. So I think the future of AI security is client-side training. But I did promise it would be about 30 seconds, and I'm kind of done. I really appreciate your patience. Hopefully there was a bit of something for everyone there, and maybe some ideas to take home, and really thank you for your time.